The biggest struggle for me is making sure your data is connected and housed in a place where you can actually learn from it. So AI is only as good, digital twins only as good as the data. It's garbage in, garbage out. So if you don't have that data connected, you're behind the game.
Hello and welcome to the Pumps and Systems podcast. I am your host, Tom Baer, a managing editor at Pumps and Systems magazine. Today we're speaking with Kevin Lysyk from Aquatic Informatics, who's going to be telling us all about AI and digital twins in the water industry. So without any further ado, let's get into the episode. So welcome to the Pumps and Systems podcast. Thank you so much for being here. How are you doing today?
I'm doing great. How are you doing, Tom?
I'm doing pretty good. So before we move into our main topic, would you mind introducing yourself? So tell us a little about who you are, what you do, anything you feel like sharing.
Sure. My name is Kevin Lysyk. I'm the Chief Technology Officer of Aquatic Informatics. I'm very focused on software. We are a software-based company. We are both in wastewater, drinking water, and the environmental software as well as IoT, a lot of AI type stuff. My background is, as I said, software development. I'm a computer scientist by trade. First half of my career was being a software developer. Last half, more management and sort of executive type stuff. I'm not a hydrologist by trade. I've been through a million different industries from, video surveillance to customer research. I built wearables. I've been in health tech. So, maybe to do my best Liam Neeson impression, what I do have is a special set of skills, and it's really about focusing on, delivering value. And that's why I'm really excited about this talk about AI, digital twins, stuff like that, because I really feel there's such an opportunity in this space to actually solve problems better. And yeah, so really looking forward to this conversation, Tom.
Okay, and yeah, as you said, we're going to be talking about AI and digital twins in the water industry specifically. And we always like to get started with what we call the absolute basics. So, for anyone who's unfamiliar, could you give us kind of the basics of what do we mean when we talk about a digital twin? What exactly is that for anyone who's unfamiliar?
A digital twin isn't something that's new with all this, the AI hype that's going around. So really, a digital twin is essentially a software copy of a physical model. So you take a wastewater or drinking water plant, you're going to have different aeration basins, and you're going to have influent, you're going to have your aerobic and anaerobic, you're going to have your effluent as well. And what it can do is actually take that, so you don't have to go to physically to the part of the plant to actually measure things. You can actually see a software copy of it. And one of the biggest transformations of that is that it's not just showing you what's going on right now. I think what, a lot of the revolution, shall we say, with AI, and that is that it's moving to prediction models, right? So you can actually say, if I, tweak this chemical or this aeration basin and, added more energy here, what would it actually do to it? So, but yeah, it's essentially a digital copy of a physical space, and it's not just, unique to the water industry. It's used all over the world. So.
Thank you. Very good. A very good primer on digital twins. So, moving on to AI. Now, of course, we see AI all over the place, but how is AI reshaping industrial sectors specifically? And what lessons do you think the water industry can draw from that?
Again, like one of the bigger revolutions right now is that we've for the longest time, we harken back to like the days of the internet and when everything started getting connected and put in a back end databases. We've been data rich but insight poor for a long time. We've just been inundated with data, like in our daily lives, in our work lives all the time. And how do you make sense of that data? So I think the shift is moving from being reactive with this data, is that, oh, this, I'm not in compliance here, this, parameter isn't quite where it needs to be, to actually saying in a couple days, because there's going to be fluvial or pluvial flooding, extra rain here. We need to actually be proactive and understand that that's going to happen. So we can actually, it's called like shifting left. You actually take more action earlier rather than having to be reactive with it, which reduces downtime, reduces chemical usage, energy usage, reduces savings. So I think that's the biggest benefit I see here. And I'll really point out right at the bat, and you'll notice this throughout this whole talk, is we still need humans. We still need human in the loop automation. the information that we have now, where we're at, it might still be 5, 10, 15, 20 years away before, computers can just do everything and you hit the easy button. So I think it's more about giving that information, disseminating that information so that humans can actually make the correct solution for it.
So there's a lot of pressure for water utilities to modernize these days. So how do you think digital transformation is reshaping the sector today, and what role do digital twins play in all of that?
I think the pressure to digitize, there's more pressure now with AI, but I think where the water industry, in my opinion, is a little slow to change and respond. And I think a lot of it's to do with capital budgets and it's generally a money-based issue. But the biggest struggle for me is making sure your data is connected and housed in a place where you can actually learn from it. So AI is only as good, digital twins only as good as the data. It's garbage in, garbage out. So if you don't have that data connected, you're behind the game. And there's still some small plants that are still doing things on paper or maybe Excel, right? So they get to that next level. And there's some that actually used a consolidated system that can aggregate that data. But one of the challenges is that oftentimes there's disparate systems. You have a different system for your SCADA, a different system for your water information management system, different one for your, financial side or for effluent. But if all of that data was in the same place, then you can start really making smarter water decisions. So I think in terms of the digital transformation, it's making sure that all of your devices, all of your data is connectable, one. Two, it's actually connected, and three, it's in the same place so that if you do want to start passing this to, AI, LLMs, digital twins, you can actually have that in the same place. So it can make those smart decisions because it's only as good as the data that you have.
Yeah, and you mentioned LLMs, which segues very neatly into my next question, which is next, let's talk about large language models or LLMs. So what are they, first of all, and what role do you think they play when it comes to operators and engineers accessing technical knowledge?
Yeah, so large language models, as the name suggests, is based on a massive amounts of data. So you can sort of think of it that we always had the internet, we always had this data. You could always go and figure out what you needed from it, but it was really hard to make those insights. So what an LLM does is it takes all of that data and it democratizes it. So normal people can actually ask the questions like you would to your brain. It's like, oh, how do I actually, who scored the most goals in the NHL ever, right? Like that's a really simple use case. But for water, it's sort of like how do I actually change things so I'm reducing N2O within my plant, and it can actually give you some of that information based on millions of scientific papers and whatnot. So if we take it to within a plant, again, it goes back to my data point, is that you need the actual data to feed to the LLM. Everyone and their dog these days is using LLMs as almost Google on steroids. They're using it to figure out, with the massive amounts of information, how do I actually get an answer or make sense out of this? And people are using that so ubiquitously in their personal life, they're expecting that in their business life as well. So one of the trends that I'm seeing, as a shift there is that the same way that people have the wealth of human information in their pocket with a cell phone, and they use it almost most of the time audibly just to ask these questions, they're expecting that as well in their business software. So if they do have that data hooked up, then it actually levels the playing field of that someone that's new could actually come in and ask some of these questions that someone with 25, 30 years of experience might have in their head, and they might know this, off the bat. But so that's why it sort of democratizes things. And then when you look at digital twins specifically, it helps you identify all of that experience and what exactly you would need to do to make sure that you're in compliance, but still reducing the cost and the spend in terms of chemical usage and energy usage to run the plants. And there's far-reaching, aspects, not just with wastewater drinking water. There's industrial, like food and beverage. You can even talk about smart, residential metering and smart distribution of water. Sustainability and scarcity of water is a huge concern these days. So it's not just being able to produce the water, it's being able to put it in the right places at the right time to actually, whether it's, forest fires, whether it's, drought, being able to make decisions like that. And my vision is if you think of like nanotechnology, like we're far away from having a water molecule sensor, but essentially if we have all of the data, and some municipalities have this, they'll have the influent in the environment before wastewater plants. They'll have the influent going out of it. They'll have the influent in drinking water plants. They'll have going into residential areas. They are able to see usage. So they essentially have the full end-to-end water data, and that really helps us when it comes to smart distribution of water and scarcity of water. So that's one of the things that I find so amazingly intriguing about where we're heading with AI, is that it can really help that sustainability problem.
And when it comes to industry professionals, what misconceptions about AI do you encounter the most?
Yeah, I think that it's either magic and the coolest thing, or that it's pure evil and it's going to destroy everything. So I think the answer's in the middle there. It's as good as how you use it and the use cases. And what I find is that our customers don't care if it's AI based or not. They care if we solve their problems better. And I think the same way that someone doesn't buy a smart car and just hit the automatic drive for me button, there's a trust and a change management aspect. So I think executives at companies, they can't expect just to say we're going to do this AI thing and everyone accept it. You have to actually build up that trust, and I think that's a challenge that we have for our customers as well. And that's why I think the human in the loop automation is so important, is that you identify the information that people have that's generated from AI, and you start building up that trust, and you start figuring out how to utilize that in their general process. And there's also a feedback loop there, that sometimes AI isn't right. Sometimes the data was bad going in. Sometimes there's AI hallucinations. It doesn't take long for me to trick an LLM model that 2 + 2 = 5, right? If you put enough information in there, it will assume that. So there's still that logic, safeguard thing that you need to do. The whole recent stuff with the Department of Justice and Anthropic was really around removing those safeguards. And I think, like, you go back to Isaac Asimov's model, where it's like, it was more robotic based, but it's like robots can't harm humans. That's like rule number one. And then everything is sort of built upon that. It's the same way as that. We need to make sure that there's those safeguards, there's the checkpoints, there's if data is wrong, being able to, feed that back into the model. So I think, yeah, when it comes to some of the misconceptions, the biggest thing is that the data matters so much. And I think making sure the data is clean and pure, and if there comes to, data like drift and, anomalies, I think we need to help identify those, and get humans in the loop to actually fix those, so that we're tweaking the model so it can actually make better decisions.
So, are there any strategies that you think are good for balancing compliance with cost efficiency? And how can AI help with that?
Yeah, I think this really talks about the digital twin space as well. I think one of the challenges we have is that water is such a compliance and regulatory based business, that oftentimes the pendulum swings too far the other way. Is that I'm just going to throw more chemicals at this, more energy usage at it, because I don't want to get fined. I don't want to make my community sick. But oftentimes it's just throwing money away. And it's not just money. If you think about the sustainability part as well, like if you're talking about nitrification and denitrification, there's greenhouse gas emissions from that. So you got to think about the full, sustainability of making sure you have things at the exact right level to actually clean, whether it's wastewater, drinking water, whether it's industrial cleaning of food and beverage as well. Um, and and that, I think, is really where digital twins can come in, is that this is physics and chemistry and math. And the AI part comes in when you talk about the influence and the predictions in terms of how things are going to change in terms of your inputs. But really, it's taking all the guesswork out, and it's taking out that buffer that people use in terms of the fact that they are still compliant. That to me is the biggest revolution, is once your data is pure and clean, and that you can actually have this confidence, it tells you how to do that. And again, you're still going to have the guardrails. You're still going to be doing that testing after it goes. So that's how we're using it successful. And we're getting tons of feedback that are like, thank you. You helped us save, 35% in terms of cost efficiencies, and reducing greenhouse gas emissions, which is a huge movement in Europe right now. And I see it as the digital twins, that it's really driving that revolution.
And how do you think organizations can build confidence in their data to support better decision making?
That comes through a whole bunch of different aspects. So it comes through, regular maintenance and support of their devices. Like there's anomaly detection when things spike. That could just be dirty data. There can be drift where something just slowly, like you don't notice it day over day, but if you look at a year or two, maybe the readings are off by 5-10%. And so I think proactive maintenance of devices and sensors, I think is a really big portion. Across the industry, it's really expensive to do what's called a truck roll, to send somebody out for support of a device. If they come there not knowing what the problem is, maybe it's a 15-year-old device, maybe it's end of life, maybe the light or the pump cycle, the valve cycle, like maybe some of these things are common to failure. So AI can really help identify that based on this part number, based on these internal parts that are in it, we can really predict like where these things are going to fail and the confidence of your data. So when I say garbage in, garbage out, that's a very broad term, but you can actually understand the confidence of your data. Maybe it's 95% confident if it's this one device and it's only 5 years old and we know it still has a longer lifespan. But if you can actually do that proactive maintenance to send somebody out to actually make sure that, these devices are up to snuff, then you're going to ensure that your data is there. And then also the, regular reports, regular making sure that AI, it's way different between smaller plants and larger plants. Smaller plants, oftentimes you don't have one person in charge of the data quality. It's maybe there's off the side of their desk job. And then large plants, they have hundreds of thousands, if not millions of time series data, key value pairs to actually look at this stuff. How do they focus their attention on that? That's really the challenge. So AI can really help you, cut through all the crap, the things you don't need to look at for troubleshooting, really just to focus on the areas that are really important to you that you need to figure out.
So, what lessons do you think we can draw about bridging operator intuition with model based guidance?
That's interesting because I think the model-based guidance needs to have that operator intuition. So if you've got 30 years of water experience, we need to get that out of your head and into the actual model. So when we talk about training and the data and some of the predictions and the connections that AI can make with that data, we can also get from humans to actually put that in the model as well. So that's another reason why I think the human in the loop automation is good, so that if AI is creating some of these summaries, we can help tweak it to what the actual truth really is. We have this gray wave going on in the industry right now where there's a lot of, professionals that have those 30 years of experience that are starting to age out and retire, and these new people that are coming in. And it's not easy to disseminate 30, 35 years of experience, within the 6 months you have for knowledge transfer or whatever it is. So, being able to actually put that into an actual learning model, whether it's LLM, whether it's something agentic, whether it's these digital twins, I think is pretty important and huge. And then I think, there's the other aspect is once these models are in, I think it helps train these people a lot better because it really identifies the things they should be focused on as well.
Yeah, and what does that process look like of taking these veterans of the industry and getting their knowledge into the AI or into the system?
A lot of it's training-based models. So in the same way that when we say that it's really focusing on, here's a bunch of data that I think is interesting, that these don't look right to me. Tell me if this is it's okay, like maybe this wasn't even good to bring to your attention. Tell me if this needs more digging. Tell me exactly why this is wrong. Tell me what you potentially could think the cause of this was. And so it's that feedback loop as well that doesn't just say this data is wrong, you need to fix it. It says I think this data is wrong, you tell me if it really is wrong, or why it is or isn't. So there's that feedback loop to help train the model, because oftentimes if models train themselves, sometimes you can get less than desired behavior and it builds up upon wrong answers. So if you can help nip that in the bud, it's super helpful.
So, with increasingly strict permits, how can utilities use predictive tools to avoid violations before they occur?
Yeah, it goes back to what I was talking about with digital twins and the predictive aspect. And one of the bigger variables is the influent. You can see this in food and bev, say, dairy farms, and oftentimes there will be produce farms next to dairy farms. And if there's flooding and you've got, one or two influent tanks you can draw from for cleaning your spinach, let's say. But when there's flood, there's going to be runoff from the dairy farm next door, which, hey, it's got cow manure. So you can help predict that and understand things before you start washing your produce with dirty water. So that's one example, but I think the biggest thing is that shift from reactive to predictive. And oftentimes, once we know there's a violation, there's loss of money, there's loss of time, there's loss of energy. So if we can start identifying that a bit earlier, again, that shift left mentality, then I think we're much better. And there's so many applications for this across every single industry: wastewater, drinking water, food and bev, mining. Like water's used in so many places, right? Like the most ironic thing is that AI doesn't work without water because water needs to cool the data centers that actually produce this. I think every query is about 1 millimeter of 1 milliliter of water, and oftentimes that's ultra pure water depending on how they're cooling it. So even that, it's very meta, but even running AI requires water that actually needs to understand the quality of that water to run the AI. So it's a bit mind blowing if you think of that.
Let's talk next about digital forecasting. So, what role does it have in helping utilities meet greenhouse gas reduction targets?
Yeah, this is huge in Europe right now. There's a big movement to reduce specifically N2O. So N2O is interesting because it's about 300 times as harmful for greenhouse gas emissions as say carbon dioxide. And it's very prevalent in nitrification and denitrification process in water. So a lot of times companies don't really know where to start. They know there's compliance and regulations that's coming. They know they're going to be fined. So that the whole industry wants to help customers solve these problems, and it's a win-win situation because customers don't want to be fined, and companies can see, hey, I can actually solve this problem for the customers. That's going to end up buying our software. So I think with it, there's a lot of really standard models out there that have been doing this for a long time. A lot of this is, chemistry based, physics based, math based. Again, the AI comes into it when it's more that predictive piece. But we're seeing 30 to 35% reduction in N2O specifically, and they're so thankful because it's such a looming compliance and regulatory problem that they don't necessarily have the expertise to solve. So if you can actually give them that model that's been trained on, millions and millions of data points across, different industries, different plants, and actually give them that confidence. And again, like show them this is how you're still able to stay in compliance with actually producing whether it's wastewater, drinking water in your plant, but still reduce your greenhouse gas emissions. It's a win-win situation. So we're seeing lots of success in that, and I think the whole industry is moving that way. I think Europe's a little ahead of the game there. I think in the US right now, it's usually a little more about nitrification, but the use cases are far reaching beyond just N2O and greenhouse gas emissions. And it's so huge because it makes sure that you're still within compliance. It reduces your cost for chemicals and energy usage, and it reduces greenhouse gas emissions, which it impacts everyone's sustainability efforts. So
Yeah, absolutely. And it's nice to see AI doing something to improve the planet. So there's a trade-off there.
exactly. And we would be complete hypocrites if, us as a company, like we have sustainability goals. We're trying to get 54.6% reduction in our scope 1 and 2 greenhouse gas emissions by 2033. We're planning on a 1.5 degrees Celsius heat up of the planet by that. So we would be a complete hypocrite if we started using AI that's actually doing more harm on that than good. So one of the great things, if you look at the Azures and AWSs and OpenAIs, is they're starting to actually publish their sustainability as well, so that I know how much water and how much energy I'm using for each query, so we can build that into our model. So if we're solving this N2O, gas emission as an industry, but we're creating a different problem. It's not it's not very sustainable. So I'm a huge believer in AI that's sustainable, and we're getting better by the day. Like this is a huge changing every single week. The actual AI models are changing, and the AI models are starting to build new AI models. Right? There's more of an efficiency at scale right now. So some of that the cost and the water usage for some of these AI queries are coming down quite significantly as well.
So, a lot of utilities face capital constraints. So, how can process modeling help when it comes to reducing costs, saving money, things like that?
Yeah, it really helps you fine tune all of the hardware, the devices that you actually need. A lot of times they're using, they're hiring new operators, engineers, consultants to help them figure out this stuff as well. So it's certainly more, you know, they throw money at it to actually solve the problem. So if there's one system that can actually bring all of this data together and actually help, democratize this and give it to people to help them make some of those problems, I think it really helps. And when you talk about the hardware piece, it really helps you extend the lifespan of some of your devices. So a lot of times people will just replace their sensors because the data is all weird and they don't quite understand why. But if you can have that proactive maintenance that I talked about, they can certainly extend their lives of it. They can have that confidence in the data, so they can actually reduce some of those, capital and hardware expenses as well.
And how do you think digital twins can reshape things like training, collaboration, and decision making across the whole utility workforce?
It's sort of what I talked about before is that you have that person with 30, 35 years experience, aging out. Maybe they didn't overlap with some new, employee and associate. So if we have that actual system that has that knowledge in it and really understands how to run and tweak that plant, again, still with safeguards, still with, humans that need to come in there and actually validate it. I think it's hugely helpful and valuable. And then when you look at LLMs, the ability to actually disseminate all this aggregated knowledge, all of the scientific papers that you have, all of those, the internal documents and stuff, you can actually ask those probing questions. I use it all the time in my life. I'm certainly not I don't have a brain the size of, some of these data centers. So for me to be able to ask this information and get some of these answers, I think is hugely valuable. And you'll see, I see the shift is that digital twins, LLMs, and some agentic modeling will be very huge for the future of enterprise software, and that people will just expect it as they do in their daily lives. Will just expect to be able to ask those questions and get that information from the massive amounts of data that we have in your business life as well.
Yeah, and speaking of the future, how do you see AI evolving in the industry over like the next 5 years or so?
It's quite fun to see the massive amounts of change. So I'm, very focused on AI for software development, and I know that 2 months, things that were true 2 months ago are no longer true now. Like it's changing so fast. So to me, I think the biggest thing is about how companies adopt it. I think we all know that we're a little bit slow to adopt things in the water space. So I don't think it's going to be huge, double and triple the technology within a week or two. It is more, small little steps. But if people aren't actually integrating this stuff for years and years, they're going to see a huge technology shift. So I think that the connectivity of data is certainly a big shift that people are going to be more focused to that, which brings up a lot of privacy, security, concerns. Every time you use like a chat GPT or OpenAI query, you're giving it that information to something external, which is great if that's not proprietary or private information. So if you use some of the software and the systems like we have and other people have in the industry, it can make sure that only your company has access to it. So it puts the guardrails on it as well. So I think the democratization of the information for building the models is great, but when it comes to sharing your own data, you want to make sure that as a company you have control of that data, you know where it's going. So I think that'll be a big shift as well. But in terms of AI models are building AI models right now. So some of the insights that we can get out of it is if we give it the data, it's not that we need to say, I want you to use this data to get these insights. You have the data and you say, tell me what the insights are. Tell me how to actually run this plant better. Tell me where some of the inefficiencies are. That to me is the biggest shift. Instead of us thinking we need to do X, Y, or Z, we're told that these things can actually improve your plant and efficiency. So it's an extremely exciting and sometimes scary future. But it's amazingly um, optimistic on what we can do for the planet and for the water and just for making sure that that smart distribution and the sustainability of water is taken care of in the future.
So, before we wrap up, is there anything else you'd like to say or any final thoughts you'd like to leave us with?
I think I pretty much hit on most of it. Yeah, I don't think anything else other than it's been an awesome chance to talk about this stuff, Tom. I'm pretty passionate about it, and yeah, I can't wait to see what we're gonna do in the next 5 to 10 years with AI.
Sounds great. Yeah, and thank you for being here and telling us all this very interesting stuff. I definitely learned a lot that I didn't know before, so I'm sure that our listeners and viewers are going to enjoy it.
Thanks so much, Tom.
Huge thanks to Kevin for taking the time to speak with us today about AI and digital twins. If you're listening to the podcast and would like the chance to watch it, head over to our YouTube channel to see the full video version. That's going to do it for this episode. Thank you so much for listening or watching, and we will see you next time.